All right, so we are going to finish up our nomenclature unit by looking at acids and bases. Acids are a type of ionic compound, but they have their own set of naming rules. Bases do not have a new set of naming rules, but you need to recognize if something is a base. So looking at acids first, an acid is a compound that contains one or more hydrogen atoms and will produce hydrogen ions, or H plus, when dissolved in water. So these tend to start with H. So it'll be H and then some other anion is attached. So an acid will have an anion combined with as many hydrogen ions needed to balance the charges. Like I said, these are still ionic, so they still have to crisscross charges when writing out formulas. So the chemical formula is usually this HNX. So the H is your hydrogen ions. X is whatever our anion is. This can be monatomic, so it can be something off the periodic table in that top right-hand corner, or it can be a polyatomic anion. And the N is going to be the subscript on hydrogen that tells how many hydrogen ions are present whenever we crisscross and balance the charges. You're never going to add a subscript onto the anion because hydrogen is a +1. You don't have anything to crisscross over. Whenever we're naming these, there are going to be 3 naming rules for acids. And the naming rule depends on the ending of the anion. So for the first rule, whenever the name of the anion ends in IDE, so these are going to be your things off the periodic table, or the polyatomic cyanide is kind of an exception. So when it ends in IDE, the acid name is going to have the prefix of hydro, the stem of the anion name, and then it's going to have the suffix or ending of ic followed by the word acid. So HCl, it's an acid because it starts with hydrogen. Cl is chloride. So when we're naming it, we're going to have the prefix of hydro, the main part of the names, this chlor part, and then it's going to end in ic, acid. So HCl is going to be hydrochloric acid. Or like H2S, S is sulfide with that IDE ending. So following the rule, it has the prefix of hydro, the main part of the word. This one, if it was like sulfic, it doesn't sound right, so they put sulfuric acid. And if you had put like sulfic and just chopped off IDE, it would still be counted correctly. It just sounds weird. So they use the full name for sulfur instead of that sulf part. But anytime it ends in IDE, make sure you have that prefix of hydro, the main part of the anion name, and it ends in ic acid. All right, for our second rule, this is going to start looking at the rest of our polyatomic ions that do not end in IDE. So if the anion ends in ITE, the acid name does not have a prefix. There's no prefix unless it is that IDE ending. So the name of the acid is going to be the stem of the anion, the first part of the anion name, and then it's going to have the suffix or ending of OUS followed by the word acid. So here we have H2SO3. SO3 is sulfite with that ITE ending. So this is the sulfur acid. So yet again, there's no prefix on here. We could also do something like HNO2. NO2 is nitrite. So when naming this, there's no prefix, but it would be nitrous acid. These are not as common because there's not as many polyatomics that end in ITE, but we can come across it periodically. All right, and our last acid rule, this deals with the polyatomics or anions that end in ATE. So yet again, there's no prefix. For the acid name, we take the stem of the anion, and it has the ending of ic followed by the word acid. So similar to the first rule, but there is no prefix. So HNO3, NO3 is nitrate. So we're going to name this, we're going to take the nitro part, and it's going to be nitric acid as the ending. We could also do like H2SO4. SO4 is sulfate. So that would be sulfuric acid. So where like we had sulfur or sulfide, sulfite, and sulfate, that's how you can tell which anion is used, is based off of, is there a prefix or not? And then which ending does it have? You can kind of use that to figure out the formulas and stuff. All right, and writing formulas for acids. Like I said, these are ionic compounds, so you have to crisscross charges, but we're going to use the same rules for writing the names of acids in reverse to write the formula. So we're going to pay attention to which ending the anion should have. So for example, hydrobromic acid has the prefix of hydro and ends in ic acid, which is that rule 1. So that means that this is bromide, is our anion. Well, bromide is just the ion of bromine off the periodic table, which is Br with a -1 charge. Acids start with hydrogen, so it starts with that H+. And when we crisscross our charges, this is simply going to be HBr. So they're always going to start with hydrogen, but you're going to look to see if there's a prefix or which ending it has to figure out which anion was used in that compound. All right, looking at other ones, phosphorus acid. Notice that this one, there is no prefix and it ends in OUS acid. So that means this is from phosphite, which is a polyatomic. It is not on your reference sheet though. This is not one that we commonly use. So phosphite is PO3 with a -3 charge. Since it is an acid, it starts with hydrogen. And when we crisscross our charges, it is H3PO3. And then looking at carbonic acid, there's no prefix here, and it ends in ic acid. So that's that third rule where this is carbonate, which is CO3 with a -2 charge. Since it's an acid, it starts with hydrogen. And when we crisscross charges, it's going to be H2CO3. Okay. And if you look in our state standards, it says to make sure that you know these acids. These are some of the very common ones that we do. We already did HCl. That was the hydrochloric because it was chloride. NO3 we already did. The HNO3, NO3 is nitrate. So that was nitric acid. The H2SO4 I already did. So SO4 is sulfate. So that's the sulfuric acid. This last one throws people off because there's simply so many letters. They kind of get confused. If you look, there's hydrogen and then there's this C2H3O2. If you look on your polyatomic list, this is towards the top. That is acetate. So in naming this, there's no prefix. it takes the root of acetate, which is the ACET, and it gets the suffix of ic acid. So this is acetic acid, more commonly known as vinegar. So that's a very common one that we tend to come across. All right, so switching over and looking at bases. Like I said, bases are still an ionic compound, but they are ionic compounds that produce hydroxide ions when dissolved in water. So these are going to have that polyatomic hydroxide as part of their formula or their name. These are named just like any other ionic compound. So bases are named by the name of the cation, followed by the name of the anion. So for example, NaOH is a very common base. Na is sodium. OH is hydroxide. So we don't have to do anything special to that name. It's just like ionic compounds that we were naming last week. All right, and writing formulas of bases, we're going to do just like every other ionic compound we did last week as well. So we're going to write the symbol for the metal cation with its charge, then the formula for the polyatomic ion hydroxide, which is OH negative, and then crisscross and balance out our charges. So another one that we might come across is calcium hydroxide. Calcium is Ca. It's in group 2A, so it has a positive 2 charge. Hydroxide is OH negative. So when we crisscross, calcium does not get a subscript, but the hydroxide, the OH, there are 2 of them, so we have to put it in parentheses. So like I said, acids are really the only new thing that we're dealing with. Bases, we've already been writing formulas or naming them. It's just being able to recognize that if it has OH, it is a base.